Alright, the fourth topic, Newton's first law. What is it about? It's about if an object is at rest, and it will remain at rest, or an object is in motion at a constant velocity, unless an external force acts on it, it will remain at its current state. Basically, in a short word, if an object is at rest, it will still at rest. If an object is moving at a constant velocity, it will still move at a constant velocity if there's no external force act on them. When we talk about Newton's first law, the one thing that we can't avoid, or the one thing that are most important, is the net force. What is the net force? The net force is the sum of all individual forces acting on the object. We write like this: sigma f. This is a Greek letter named sigma. If the net force is equal to 0, we can say this object is at equilibrium. Let me give you several examples of equilibrium. This is an object on the ground, and it remains constant, which means it is at rest. It is at equilibrium, which means the net force is equal to 0. Why? That's because the force that acts on it, the first force is gravitational force. The next force is normal force. This is the center of mass. Imagine this. If one of the forces is bigger, like Fn is bigger than Fg, it will going upward. It will going upward, so it can't be. If the Fg is bigger than Fn, it will pull this object going downward. But I already told you that this object is stationary, which means the net force is equal to 0, which means Fn is equal to Fg. And the net force equation can write like this. F is equal to, you can write whatever you want at first. We can write Fn, let's say Fn is positive, minus Fg is equal to 0, which means Fn is equal to Fg. That's it. Another example is, this is a ground. This is a this is another object. It's on the ground, and there's a force actually pulling it forward, and it is going at a constant speed. V is equal to V naught. It's going at constant speed. Is it at equilibrium? It is. Why? Because let's draw a free body diagram first. Do you remember how I told you how to draw a free body diagram? First, let's draw a dot in the center of mass of the object that represent the entire object. The first of all, what is act on it is a force that I told you in a. Well, actually, the first force that you have to draw is the gravitational force, because every object has a gravitational force if it is on the Earth, which is Fg. The second force is the normal force. Is this object going up and down? Is it like going like this way? No. This object is going horizontally, which means the net force vertically in this direction is equal to 0, which means Fn, this is normal force, which means the net force vertically is equal to or I love to write a y-axis, because this is y-axis, usually represent vertically. Fy is equal to Fn minus Fg, equal to 0, which means Fn is equal to Fg, right? This is equally. And then I just told you there's a force pulling this object going forward with constant speed. Right now, it is not at equilibrium because the net force is not 0. Because although the net force vertically is at equilibrium, horizontally it is not. Horizontally, the net force is actually equal to F, which is not 0. Then where's another force? The other force horizontally that act on this object is the this is awful. Is the friction force, and it must have the same magnitude as the action force, because it is moving at constant speed, constant velocity, which means it is at equilibrium, which also means the net force is equal to 0. So the net force equation is like Fx is equal to F minus Ff. It's also equal to 0. Yeah, that's it.